Hello, this is Mrs. Myers, and today we're going to be learning lesson 2.6 about proving angles are congruent. We have several theorems that will be helpful to us for solving diagrams and for using in proofs. So first of all, a theorem is a conjecture or statement that you prove to be true using a formal proof. So we're going to continue investigating how to write a formal proof. We will learn several new theorems. This is just the beginning of all the theorems we will be learning. So far we've learned what's called a postulate. Remember, a postulate is a true fact that we accept as being true without proof. So some postulates were like a linear pair will always be a pair of supplementary angles. Linear pairs are always supplementary. That was a postulate, the linear pair postulate, that we accept as being true without proving it. It's just a fact. But other things we can actually prove with an actual proof, and one of the first things that we are going to learn in that category is the vertical angles theorem. So this is a theorem that we can prove with a proof. So the vertical angles theorem says vertical angles are congruent. In other words, if it is a pair of vertical angles, then they will be congruent every single time. So in this case, 1 and 3 are vertical angles, therefore we can mark them as congruent. And 2 and 4 are vertical angles, so we can mark them as congruent. We've touched on this before. Write this theorem as a conditional statement. If it is a pair of vertical angles, then they are congruent. So if you are asked to state the vertical angles theorem, which you may be asked to do, you would state either vertical angles are congruent, or if it is a pair of vertical angles, then they are congruent. What is the hypothesis? Remember, the hypothesis is the statement without the word if. It is a pair of vertical angles. And that's the given. Remember, we said that's going to be, the if part is like the given of the proof. What is the conclusion? The conclusion is they are congruent. Remember, it's the part that just comes after the then. So we are actually going to prove this theorem. First of all, angle 1 and angle 2 are vertical angles. I'm sorry, angle 1 and angle 3 are vertical angles. In our diagram, okay, we're not going to mark them as congruent yet, actually, because first we have to prove this theorem is true, and then we'll be able to, from then on, mark all vertical angles congruent when we see them in a diagram. But first, we need to prove this theorem. Okay, so first we're going to state our given. Angle 1 and angle 3 are vertical angles. And that reason is just given. And then we're going to say from there, not much we can say, we're going to look at our diagram. When we run out of things to say in a proof, it's really a good idea to look at our diagram and see if there's anything in there that we can relate to. So I see some linear pairs here. So I'm going to say that angle 1 and angle 2 are supplementary because I know that angle 1 and angle 2 are a linear pair. And by the linear pair postulate, if two angles form a linear pair, then they are supplementary. So I'm going to say angles 1 and 2 are supplementary. And in the same step, I'm going to say angles 2 and 3 are supplementary. We know they add up to 180 because they sit on a line. They are a linear pair. Next, I'm going to say, all right, well, if 1 and 2 are supplementary, what can I say about them? Well, I know that supplementary means they add up to 180. So I'm going to say the measure of angle 1 plus the measure of angle 2 equals 180. And in that case, since 2 and 3 are supplementary as well, I'm going to say the measure of angle 2 plus the measure of angle 3 is 180 as well. How did I know that? What's my reason? Well, if somebody says, hey, 1 and 2 are supplementary, you could say, oh, that means they add up to 180 because you know the definition of supplementary. So really, you're asking yourself, what do I know? How do I know this next step is true? So that would be definition of supplementary. Now, since I have the measure of angle 1 plus the measure of angle 2 is 180, and the measure of angle 2 plus measure of angle 3 is 180, since they're both equal to the same amount, what I can do is take 180 and take it out of this equation and replace it with this. Since 180 is exactly equal to the measure of angle 2 plus the measure of angle 3, I can take out the 180 from the first equation that I wrote, measure of angle 1 plus measure of angle 2 equals. Now instead of writing this 180, I'm going to replace it with what's equal to 180, which is the measure of angle 2 plus the measure of angle 3. This was that quick change substitution property. Took out one thing and replaced it with something equal to it. Just a little hint here, whenever you have a step that says two things are equal to the same amount, you could always set those two things equal to each other by substitution. Now I can say, well, both sides have this measure of angle 2 on it. Both sides of the equal sign have measure of angle 2. So I can just subtract that measure of angle 2 from each side, and I get that the measure of angle 1 plus equals the measure of angle 3, because I just subtracted the measure of angle 2 from both sides. Oops, subtraction property of equality. Subtracted measure of angle 2 from both sides. Well, if the measure of angle 1 equals the measure of angle 3, then I can say angle 1 is congruent to angle 3. Remember, we said anytime two things are equal, you can say they're congruent. And anytime you have two things are congruent, you can say they're equal. And in both cases, your reason is going to be definition of congruent. Okay, so now we've proven the vertical angles theorem. Now it's become a theorem since we've proven it, and now we can use it in a proof. So in this case, we have another proof here, the vertical angles theorem. Within a proof, we're given that angle 1 is congruent to angle 4. So if I'm given that fact, I can come over to my diagram and I can mark my diagram congruent. 1 and 4 are congruent. I want to prove that 2 and 3 are congruent. I don't want to mark that on my diagram because it's not a fact that I know yet. It's something that I'm trying to prove. So I'm going to start with angle 1 is congruent to angle 4, given. Now I know angle 4 is congruent to angle 2. How do I know that angle 4 is congruent to angle 2? Well, because we just proved the vertical angles theorem. Well, if angle 1 is congruent to 4 and 4 is congruent to 2, that means 1 must be congruent to 2. This is that zigzaggy 1 is to 4, 4 is to 2, therefore 1 is to 2. That's the transitive property of congruence. Now I can also say that angle 1 is congruent to angle 3 by the vertical angles theorem. So now I can get to my proof statement. Since 1 is congruent to 2 and 1 is congruent to 3, I can say angle 2 is congruent to 3, again by the transitive property. Okay, hopefully we're getting the hang of these proofs a little bit, but let's look at some more theorems. Theorem 2.2 says it's the blank supplements theorem, and we're going to fill in that blank in a minute, but I want you to try to discover what that blank might be. So it says if two angles are supplements of the same angle or of congruent angles, what is this? Okay, go away. Then the two angles are blank. Okay, so that word that goes in here is going to be the same word that goes in here. Let's discover what that relationship is. So first draw two angles that are supplements of the same angle. So we're going to use angle A. We know it's 60 degrees. Right now I'd like you, by yourself, right here, to draw an angle B that is supplementary to angle A. If you know that A is 60 degrees, think about how many degrees angle B needs to be. Okay, hopefully you did that on your own. And angle B is going to be 120 degrees because we need it to be supplementary or add up to 180 with 60. All right, now draw angle C, which is also supplementary to our original angle A. So draw angle C. Of course, that's got to be 120 degrees also. So this is what this theorem is describing. Two angles that are supplements of the same angle. B and C are both supplements of angle A. So they're two angles that are supplements of the same angle. Now, how many degrees is angle B? We said 120. C is 120. So what's true about angle B and angle C? They're congruent. Angle B is congruent to angle C. So in our theorem, if two angles are supplements of the same angle, then the two angles are, well, we just found out they must be congruent. So this is called the congruent supplements theorem. Now this little parenthesis here says if two angles are supplements of the same angle or of congruent angles. So in other words, if I did this same exercise and I said angle A is 60 degrees and angle D is also 60 degrees. So now these two angles are congruent. A and D are congruent to each other. So if I then said B is supplementary to A and C is supplementary to D, B and C are still going to be congruent because they're supplements of two angles that are congruent angles. So that's what that little parenthesis means there. All right, so let's see this next theorem. The blank complements theorem this time. Same situation. If two angles are complements of the same angle, what's going to happen? Well, we could go through the same exercise. We have angle A is 60 degrees. Now draw angle B that is complementary to A. You guys do it on your own. And then draw C, which is also complementary to A. And fill in how many degrees is angle B and how many degrees is angle C. So hopefully you did that on your own and you came up with a 30-degree angle here and a 30-degree angle here. And since they're both 30, that means that they are congruent again. So again, this word is going to be congruent. And we've got a new theorem called the congruent complements theorem. Well, let's discover a couple more theorems here. Okay, so we have the right angles theorem. If two angles are right angles, then they are blank. So let's discover this a little bit. Draw two angles that are right angles. All right, there's one right angle. There's another right angle. how many degrees is each angle? Hopefully we remember that each angle is 90 degrees. Well, if both angles are 90 degrees, again, what can you conclude about these two angles? They are congruent. So that's as simple as this theorem is. The right angles theorem says if two angles are right angles, they're congruent to each other. You will see that this is useful in proofs later on. It might seem very obvious right now, but eventually we're going to need that in proofs. Okay, so the last one here is theorem 2.5. If two angles are congruent and supplementary, then each angle is a blank. All right, well, let's try this. Draw two angles that are congruent and supplementary. I'd like you to do this on your own. Really think now. They have to be the same measure as each other, and they have to add up to 180. So how many degrees does each have to be? Well, 180 split into two congruent pieces, each one has to be 90. So what kind of angles do we have? Oops, I didn't draw that very well. Each angle is a right angle. So that's what this theorem says. If two angles are congruent and supplementary, they must both be right angles. Okay, so that's it for the theorems. We are going to discover how to use those in proofs a little bit more. But there's two proofs to practice here. You should try them on your own and then turn the video back on and check your answers. Okay, so you can check your answers here for this algebraic proof. First step was given. Second one was distributive property. The third one, you're just simplifying, combining like terms here. Then we have 6 equals 6 is the reflexive property. And then 3 equals x is subtraction. And then x equals 3, we're just switching the order, so that's the symmetric again. Okay, and this one here, state our givens first. Then we can say, this is sort of an optional step, but you can say that angle 2 and 3 are a linear pair, and that's just by looking at the diagram and you see with your eyes that they are a linear pair. So that is the definition of linear pair. You know what the definition of linear pair is. You were able to look at the diagram and identify what they are. You can state them as such. Don't know why that keeps popping up. Angle 2 and 3 are supplementary, therefore, because we know that if two angles are a linear pair, then they're supplementary by the linear pair postulate. Then we can say, well, since they're supplementary, angle 2 and 3 are 180 by definition of supplementary. Now we have this step 4 and this step 1 where we have two things both equal to 180 degrees. And remember we said anytime two things are equal to the same amount, you can set them equal to each other by substitution. Now we subtract the measure of angle 3 from both sides and we get angle 2 equals angle 1. Switch the order by symmetric, and then angle 1 is congruent to angle 2 by the definition of congruence. Okay, thank you.